Welcome back. We are going to cover just a few things we're going to add to last week's topic for this week's quiz. Last week we talked about as I go left to right across, those are called periods, and as I go up and down, those are called families. And as I go across a period, I'm adding valence electrons. So this lithium here would have one valence electron, and that's the number of electrons in its outer shell. Beryllium would have 2, boron would have 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, and neon 8. So as I go across, I'm adding the number of electrons on the shell. Well, what's a shell? A shell is a layer of those electrons, and the outermost shell, how many is where the valence electrons are. How many shells you have has to do with the family. As I go down the family, this has 1, this has 2 shells, 3 shells, 4 shells, all the way across. All these have 4 shells, 5, 6, and all of these would have 7 shells. So that is what we covered last week. We're going to add just a couple things this week. Knowing what we know now, as I go left to right across a period, we know the atomic number goes up. All the electrons are in the outermost shell, same distance, but as I go across, there's more protons. That's a positively charged subatomic particle in the nucleus, which positives will attract negatives. So the more positives, it's going to pull those electrons in tighter. So as I go across, it's going to want to pull those electrons in that shell closer to it. It's going to hold on to them tighter. As I go down a family, on the other hand, I get more shells. And the further away you get, the harder it is to hold on to those electrons. It's going to hold on to them less tightly because imagine you're trying to guard your candy, and your candy's in your room, and if you're in your room, you can guard it really well. But if you're in your basement watching TV and the candy's up in your room, it's too far away to guard. You can't hold on to it as tightly. So as I go down, they're farther away. The valence electrons are farther away. You can't hold them as tightly. So the trend is, as I go across, it holds them tight, more tight. As I go down, it holds them less tight. So I gave you 3 terms this week that we're going to look at. The first one is atomic size, and that is how large an atom is from the center point in the nucleus all the way to the last electron on the outside, the valence electrons. So as I go across, remember, it's holding those electrons tighter, more pluses, more protons. So it's pulling those valence electrons, those shells, closer to it because there's more pluses, more protons. So as I go left to right, the atoms get smaller. As I go right to left, because there's less positives to hold, less pluses to hold those shells tightly, the atoms get smaller. So left to right, they get larger. Right to left, the atoms get smaller. Now up and down, as I go down, the atoms get larger because there's more shells. There's just more shells, it gets bigger. As I go up, there's fewer shells. So atoms are bigger as I go down and smaller as I go up. The next topic we did was ionization energy, and that is the amount of energy it takes to take 1 electron off. If I put that element in a gaseous form, I make it into a gas, and then I want to pluck an electron off of it, how much energy is that going to take? Well, as I go left to right, it's holding those electrons tighter. So it's going to take a whole lot more energy to pull it away because it's holding them tighter. So left to right, it takes more energy to pluck them off. As I go down to take 1 electron away, it's further away. It gets further and further. So it's easier to rip that one away as I go down. So ionization energy increases as I go left to right and decreases as I go top to the bottom. The last one is electronegativity, and it's similar to ionization energy. It is how tightly that atom or that element wants to hold its electrons, how hard it is to take them away, how tightly it holds them. So same as ionization energy, if I go across, it holds them tighter. As I go down, bigger shells, it holds them more loosely. So those are the trends. And so what you should be able to do on the quiz is if I give you 3 elements, you should be able to tell me which one's most electronegative, which one's the least electronegative, and so on. We don't look at noble gases because they don't react, but fluorine is the furthest to the right and the highest. It's the most electronegative, stingiest of all. And francium, furthest this way and the farthest down, is the least electronegative of all. Hope that makes sense. Quiz, everything we did last week and this stuff, we won't do the density this week. We're still working on that. We'll add that to next week's quiz. But these are the topics. Good luck tomorrow. I hope this helps. Thanks.